Dear colleagues, it's a great pleasure to be here today, even the last one, maybe you are very tired, but it's a pleasure to participate in the panel called ICT for a Green Railway. We are going to talk about green projects that we are developing. I'm Ines Vadillo. I've worked in the Spanish Railway Infrastructure Manager at IF since 2010. I'm currently head of Research and Development Sustainability Project in the department, so I'm responsible for the green projects, mainly related to energy storage and hydrogen. I was invited today to talk about a project called Rail Energy Storage System, developed in UIC. But this project, it will be presented by Pablo for the technical part. And at the end, I'm going also to talk about other projects that we are developing in the department. One is reversible substation, was mentioned also this morning. The other is FP4, Rail for Earth, in European EU program. And the third one is FCH2 Rail. So now let's move through the Railway Energy Storage System project. Pablo?
Okay. Hello everyone. My name is Pablo Urosa and I'm working with Ines in NADIF, managing research and development projects in the area of sustainability and energy. I'm an industrial engineer with electrical specialization and have experience working with railway simulators and managing innovation projects regarding the electrical railway infrastructure. So I will present you today the RES project. Okay, this project was founded by the UIC and also funded by it, and its main objective is to increase the energy efficiency of the railway systems using energy storage system. How do we do this? Well, we use the kinetic energy from braking trains coming into a station, and we store it into a device which is called the ESS by means of the regenerative braking of trains through the catenary. The stakeholders of the project are as follows. UIC is the project manager and they are in charge of the administrative aspects of the project. We, NADIF, act as project leaders and we are in charge of mostly the technical part of it. In collaboration, we are working with other railway infrastructure managers such as Infravel, British Network Rail, Italian RFI, Czech SZDC, or the French SNCF. So you can see that there are many infrastructure managers that are benefiting from this project. And lastly, we have incorporated as technical assistants the Institute for Research in Technology from the Spanish Pontifical University of Comillas. Okay, as the project developed, it just made sense for us to expand the scope of the RES project. At first, the ESS was only going to be used to supply the station and lowering its electrical consumption, but we thought it was also a good idea that the trains nearby could use this stored energy. And as a general rule, this is here the control diagram. It's as a really simple rule, if there are mostly braking trains nearby, the energy will come from catenary to the energy storage system. If there are mostly accelerating trains nearby, the priority will be that the energy from the ESS will go to catenary and supply these trains. And if there are no trains nearby or they are stopped, the energy will go from the ESS to the station, lowering its load profile. Okay, here you can see a general overview of the project. It started on April this year and it will finish on March 2025. The first of the tasks, which is the analysis of the state-of-the-art on energy storage technologies has already been finished, and the deliverable has already been drafted and reviewed. Okay, the first of these tasks is the review of the state of the art for energy storage technologies. We will analyze all these technologies and their most important parameters, such as power density or energy density, but also power charge and discharge, the time charge and discharge as well, the lifetime, the efficiency, the investment and maintenance costs, etc. You can see two examples of some parameters analyzed. And the objective of this task is to have a general overview of all of them and to select the two most relevant ones for a project. And the method that we used to choose two of them was to create a decision matrix. And as you can see, the 5 most relevant as a first glance technologies were selected and listed, which are the lithium-ion batteries, the electrochemical, the double-layer capacitors, the flywheel energy storage systems, the newly known superconducting magnetic energy storage systems, and the vanadium redox batteries. The most important parameters were listed, and each of these were assigned a criterion weight based on the importance that they had in the project. And for each of them, a score from 1 to 5 was chosen. So in the overall score, the supercapacitors and flywheels had the highest score of them all, and were the ones that we selected for next tasks of the project. The second task is this one, is the development of the energy and traffic simulation tool, and is the task that we are working on as right now. The objective of the task is to model a subsystem of the railway network, as you can see in the left side, being the station, the central focus. We model the station as well as the energy storage systems that has been selected, but also the electrical infrastructure, such as the substations, the catenary, or the power grid. We have to model as well the track information and also the train's technical information and timetables. All these input will go into the simulator, and a scenario will be created in which the relevant output, which is the energy savings, will be shown. This has to be included into the third task, which is the decision software tool, in which a railway infrastructure manager user will have to put its own example as a station in which he wants to know whether ESS will be beneficial to be installed there or not. This scenario will be created and analyzed with the simulation tool, and as an output, the program will give him which recommended solution ESS will be given and with which parameters to save the most energy. He also will receive a viability study in which the investment and energy savings will be shown to him. And now for the fourth and last task, Ines will give you the review.
The last part of this project consists on standardization. It will be draft an IRS that it will include the guide for infrastructure managers to implement this energy storage system in the stations and substations. It will be very helpful to select the most appropriate storage for each case. That at the end is the goal of this project. This IRS it will be finished, as we mentioned, in 2025. But we are also working in another IRS that I'm going to talk about. This IRS is related to reversible substation. This is a project, it was mentioned, and maybe someone could consider it an old project, because it's been more than 10 years working for our case, our colleagues, were developed the prototype, implementing the technology, and now we're setting up the conclusions of this technology, of these examples. Nowadays, this is a reality. We have more than 10 reversible substations in Madrid and Barcelona commuter lines, and this energy, green, is go again to the national grid. I want to point it in this project some barriers. There were not only technical barriers that could be considered, there were also economical and legal barriers. Legal barriers, for instance, that could make that in some countries, I'm not a legal expert, but I think in some countries this is not possible because the law doesn't allow to send energy for the grid, for the national grid. Fortunately, in our case, we can do it. Another barrier is considered an economical barrier, an external economical barrier could be the prices of the energy, because the electrical companies pay you, and this is not a very negotiated price. In this case, we also have the opportunity to have some money for the government, to reimburse this project, and the 30% of the investment was made for the company. Another project, a green project that we are working is FCH2Rail. This is a challenge for us. The first challenge for us was to authorize a new technology and hydrogen and battery trains to test in our infrastructure, in our lines. Due to security reasons, many people were very not happy with this project and resilient to implement it. The four main objectives of this project are develop and homologate a fuel cell hybrid power pack. I think someone later spoke about fuel cells. Demonstrate the train in our infrastructure. Improve the energy efficiency of this kind of train. And the last one, propose a normative framework. This task is one of the most difficult of the project because standardized new technology is very complicated. As I mentioned, for a company, for ADIF, one challenge was the authorization. And the 19th of May of this year, it was signed the first authorization, consigna into Spanish, to test this train. And even you can see, nowadays, we are testing the second line of this project. To conclude, I sign as an opportunity FP4 or Rail for Air project in the Eurosrail program. This is a FP dedicated to sustainability, and we are working mainly in the sub-project related to energy solutions and energy infrastructure and station. As you can see, there is also our package and a specific part of standardization and norms that it's very important. I think it's a big opportunity because the main companies of the sector are involved in this project, so it will be easy if we are all in the same way. And that's an opportunity to show you our project. Thank you very much for the opportunity to be here today, and it's been a pleasure.
Thank you all.